Hello everybody and welcome to another episode of your favorite algorithm channel. My name is Ryan Powers and today I'm going to be taking you through LeetCode 34, find first and last position of element in sorted array. Now I must admit, I am a little sick, so hopefully I'm not going to be sniffling my way through this entire episode, but we're going to soldier on, we're going to get through it, and we're going to put out this video anyway. So without further ado, let's introduce the problem. So given an array of integers, nums, sorted in ascending order, find the starting and ending position of a given target value. Your algorithm's runtime complexity must be in the order of log n. So what does that tell us? Well, that's big flashing light, right? We've got a sorted array. We need to do it in log n. Well, what are we going to do? Well, we're going to do binary search, right? We just did that in the last, I believe we just did that in the last video. So that should be fresh in our minds. So we already kind of know what our approach is going to be. So let's look at our examples here. Okay, so I guess I should cover this first. If the target is not found in the array, we should return -1 and -1. Okay, great. So here's our input array, and our target is 8. So here are the ends of 8, right? We need to find the bookends. Where does 8 start and where does it begin? Or sorry, where does 8 start and where does it end? Well, it starts on the 3rd index, and then it ends on the 4th index. So we need to find those two indices and return them in an array. And so what's this other example here? Well, the target is 6. We don't find 6. 6 doesn't exist, so we return -1 and -1. Okay, great. So as always, I suggest you try to solve the problem on your own first. And if you get stuck or you just want to see how I solved it, come check out the video. Otherwise, if you're ready to get started, come with me to the whiteboard. On the screen here, I have an array, just a sorted array. I just wanted to do a quick little recap of binary search. I know you code ninjas out there don't need this binary search recap, so if you don't need this, just kind of speed through the next 3 or 4 minutes. But if you're kind of parachuting into this video series and you have no idea what binary search is, well, then stay here with me, and we're going to go through just kind of the strategy of binary search. So what are the steps of binary search? Well, the first thing we need to do is get our midpoint, right? So our midpoint is going to be represented by this this pink circle here, and the midpoint is just the point between the ends of our array. So this right here. This right here is our low pointer, and then this right here is our high pointer, and then this is our midpoint here. And at every stage, what we're going to do is check our value. So we're looking for this search value of 8. We're going to search this array for 8. We're going to do it in log n time using binary search. So we're going to check, is the midpoint equal to the target value, which in this case is 8. And then if it doesn't equal the value, then we're going to move our pointer. So we're either going to move our our low pointer or our high pointer. So if the value is less than the target, the current value is less than the target, well, then that means if our array is in sorted order, that our answer cannot possibly be in this half of the array. So we can then move our low pointer up to be this value here. And likewise, if our value was greater than the target, well, then that would mean that we could eliminate all the values to our right. So we could then take our high pointer and move it to our midpoint, and then we would just simply reassign our midpoint, right? And we just keep doing that until we find our target. So we're eliminating half of our answers at every iteration. So let's go through one round of doing binary search just to get a better idea of how it works. So the first thing we're going to do is get our midpoint. Our midpoint is here at 5. And then we're going to check our value. So is 5 equal to 8? No, it's not. So we need to move our pointers so we can eliminate half of our answers, because 5 is less than 8. That means we want to move our low pointer. And we'll reset our midpoint to be the midpoint between 9 and 4, which is, if you sum 9 and 4, that's 13 divided by 2 is 6.5. Well, we're going to use our floor here, so we're going to go to 6. So we're going to go to 6, and we're going to check again. So we're going to check to see, is this equal to our current value? So 7, no, it does not equal 8. So we need to move the pointer again and eliminate half of our possible solutions. Well, 7 is less than 8, so that means we can move our low pointer again. And we'll find the midpoint again. So what's the midpoint between 6 and 9? So that's 15, 7.5. Left dot floor. Okay, 7. Great. All right. So now we're going to check again. Check our value. Is 8 equal to 8? Yes, 8 is equal to 8. Great. So what we did there is we just eliminated half of our answers at every iteration, checking our target value to finally come to our solution. Anyways, this is the basics of binary search, and this is the strategy we're going to use to solve this problem. So if you're ready to move on, then let's go to the next section. On the screen here, I have an array full of numbers in sorted order, and we have our low pointer here, and we have a high pointer over here, and this pink circle here is representing our midpoint. And what are we looking for? Well, we're looking for our left edge of our target answer, and we're looking for the right edge of our target answer. So that's represented here as 2 and 9 in our answer set, and of course we're looking for this target value 4. So how are we going to solve this problem? Well, we're going to use binary search to find this this left edge, and then we're going to use binary search to find this right edge. So what's the runtime complexity of this overall problem going to be? It's going to be a big O of 2 log n. And why is it 2 log n? Well, we're doing binary search once to find this edge, and then we're doing binary search again to find this edge. And of course, when we do our complexity analysis, we drop our constants. So that's going to give us a runtime of log n, which is what we're looking for in this problem. And you might be asking yourself, hey, Ryan, why don't we just find a 4, like this 4 right here, this 4 right here, and then just iterate to one edge and find that side, and then just iterate to this other edge and find that edge? Well, I would propose to you, what if our array was full entirely of 4s? We would have to iterate all the way to one edge and then all the way to the other edge, effectively turning our log n search into a linear solution, which is not what we want to do, right? We don't want to iterate. We want to get rid of half of our answers at every iteration. So I guess we do want to iterate, but we want to iterate in a very specific way. So we're going to do binary search to find this left edge, and then we're going to do binary search to find this right edge. So how are we going to do that? Well, we need to identify. So first, let's start with this left edge here. Well, what are we looking for? Well, we're looking for a number that's equal to our target, but the number to its left is not equal to the target, right? So that's kind of that's the while condition we're looking for. So let's construct our while condition. So our while condition is going to be, first of all, if the current position does not equal the target, then we want to keep looping. So what's the other case? Well, we just talked about it. If the current position minus 1, if that equals the target, well, we also want to keep looping, because if we're here at this position, well, if we look to our left, we'll see that that is a 4. So we're not done yet. We have not found the edge. So we want to keep looping while anything inside of this expression is true. And then what about our edge cases where we've terminated to one side of the array or the other? Well, we'll take care of that as well. So we'll have an AND condition here that just says while high minus low is greater than 1. We also want to keep looping. Okay, so we've taken care of our while condition. What about our pointer reassignment? So what about our pointer condition? Well, how do we know which pointer to move? Well, if we're looking for this left side, then any time that the value is greater than or equal to the target, we want to move our high pointer. So if we're here in the middle, then we would want to reassign our high pointer to be equal to the current midpoint, and we would want to move our midpoint. Okay, great. So what does that look like? Well, we're just going to check the position, the current position. If it's greater than or equal to the target, we'll do a ternary, and we'll just say that the high is equal to the midpoint. Otherwise, our low is equal to the midpoint. Okay, great. Let's go through one round of finding the left bound. Then we'll go through a round of finding the right bound before we code out this problem. So let's first get rid of this here. Okay, awesome. Okay, so first we're going to check if either of these statements here are true. Is our current position not equal to the target? That's not true. Is our current position at m-1, which is at index 6, equal to the target? It is, so we need to keep looping. So we'll do our pointer reassignment. Our current position is greater than or equal to the target. So we'll move our high pointer, and then we'll move our midpoint, and we'll keep looping. So we'll ask again, is our current value not equal to the target? Well, that's not true. Is our current value our current index -1, is that equal to the target? Well, that is true, so we need to keep looping. So we'll do our pointer reassignment. Our current value is greater than or equal to the target, so we'll move our high pointer, and then we'll move our midpoint. Okay, so let's loop through again. Is our current value not equal to the target? Well, that's true, so we need to keep looping. So let's do our pointer reassignment. Is our current value greater than or equal to the target? It's not, so we'll move our low pointer. and we'll move our midpoint and keep looping. So we'll ask ourselves again, is our current value not equal to the target? Well, that's not true. What about our current value, or our current index -1? Is that equal to the target? Well, that's not true either. So we know that we have found, so we're done looping, so we know we've found our first index. So we'll move that into our answer set, and we will now find this right bound, right? So we'll reset this problem. Okay, great. And now we just need to talk about how we need to modify our conditions here. Well, what about our while condition? Well, at first we were looking for this edge here. So we were looking at m-1 to see if we needed to keep looping. Well, this time we don't want to look at m-1, we want to look at this position here. So we want to look at m+1. So all we need to do here is just flip this sign from minus to a positive, and now we're checking on that other edge. And then what about our pointer reassignment? Well, before, when our current value was equal to the target, we were moving our high pointer. Well, this time we want to move our low pointer. So how can we modify this expression to achieve that? Well, we can just get rid of this equals to, right? The only time we want to move the high pointer is if the current value is greater than the target. Okay, great. Let's go through a round of finding our right bound before we code the problem. Okay, great. So we'll take a look at our current position, and it is it does not equal the target, right? So, or it does it does the current position not equal the target? Well, that's not true. What about the current position at m+1? Does it equal the target? Well, that is true. So we need to keep looping. So we'll do our pointer reassignment. Our current value is not greater than the target, so we'll move our low pointer, and we will move our midpoint, and we'll keep looping. So we'll ask ourselves again, is our current position not equal to the target? Well, that's true, right? So we need to keep looping. We'll do our pointer reassignment. Is the current value greater than the target? It is, so we'll move our high pointer, and we'll move our midpoint. Okay, and we'll ask ourselves again, is the current value not equal to the target? Well, that's not true. Is our current value at the current index +1 equal to the target? Well, that's not true either, right? Because that is this position right here. So we know that we have found our other index, right? So we're done looping. So we found our other index, and we can return that into our answers array. So we've found our answers. So we know now that we can use binary search to solve both finding this left edge and this right edge here. So now that we kind of know the strategy for solving this problem, let's see how it looks in code. On the screen here, I have a bunch of helper functions. So we're going to use a bunch of helper functions to code out this problem. So on the top here, we have these const, left function 1, left function 2, right function 2. Okay, so we want right function 1, and right function 2. So these are going to be our helper functions for kind of defining our looping conditions and our pointer reassignment. So we don't have to write two binary search functions. So we're going to write one binary search function, and we're going to call it with different conditional functions. So that's another helper function we have here, which is our binary search, which takes in the arguments of the array, the target, and then the two functions that we're going to use inside of this binary search. And we are going to be default assigning our pointer to be the first index, and then the length of the array for the high index. And then here we're going to define all of our high-level logic for solving this search range problem inside of the function search range, of course. So I think a good place to start is right here. So what do we want to return in our answer? Well, we want to return an array, right? And what can we return in that array? Well, we can return a call to binary search, where we pass in the array, and we pass in the target. So, okay, so it's actually the nums, right? And then the target. And then we want to pass in a call to left function 1. And then we also want to pass in, so not a call to, but we want to physically pass in the function itself. So we're going to pass in left function 1, and then we're going to pass in left function 2. So that's going to give us our left side value of the target number, the left bookend of our target number. And then we can just basically copy this down, and we can replace our calls here. Instead of calling our left functions, we'll call our right functions, and that will give us the other end of of the bookend of our target value, right? So that'll give us an array, and these two calls to these functions will return a value that is going to be the index of the first target number and then the last target number. Okay, great. So now we just need to code out some of these helper functions first. So remember, we talked about our while condition. So let's start there. So what is the left condition for our the left condition for our while looping? For how long do we want to keep looping? Well, we want to keep looping while the array at the midpoint does not equal target, or we want to also keep looping if the array at the midpoint minus 1 equals triple equals the target. I apologize if my face is blocking that. I'm not sure if it is or not. But this is just the array at the index m minus 1, triple equals the target t, the variable t. So what do we want to do for the left pointer reassignment? Well, we want to reassign the pointer to high, so we want to return true here. We'll reassign the pointer to high if the current index is greater than or equal to the target. Then we want to move the high pointer, so we want to return true. So we'll just return the expression that the array at the current index is greater than or equal to the target. Okay, so what do we want to do for the right function number 1, which is going to be the while condition? Well, we want to do something very similar, where we first want to keep looping while the current position does not equal the target, or we also want to keep looping while the current position at the current index plus 1 equals the target, right? If it equals the target, then we want to keep looping. Okay, so now let's take care of the binary search function. So this is kind of the meat of the problem here. We're going to, we wanted to code this in a reusable way, so we can use this binary search function to both find the left and the right side. And we can do that just by feeding in a conditional argument for the looping and the assignment of the pointer. So the first thing we need to do is assign a midpoint. So we'll assign a midpoint, and we'll set that equal to the floor of our high plus our low divided by 2. So that'll give us our midpoint, and then we want to loop. So how long are we going to loop? Well, this is the great part of this, is we can just pass a call to our function in to this looping condition, passing in the array at the midpoint and the target. And we also want to make sure that we're taking care of that case where we've terminated on one end of the array. So that's going to be while high minus low is greater than 1. That means we also, if both of these things are true, if both of these things return true, well, then we want to keep looping. Okay, great. So now we need to do our pointer reassignment. So that's going to be a call to our second function, passing in the array, the midpoint, and the target. And we can put this inside of a ternary. And if this returns true, then we know we want to reassign the high pointer. So high is going to equal mid. Otherwise, low is going to equal mid. And I just realized that I didn't fill out this what's our pointer reassignment for our right pointer. Okay, so in this call here to left function 2, which is going to be the pointer reassignment for our left side target value, well, we want to move the high pointer if the current value is greater than or equal to the target. Well, in this case, we only want to move the high pointer when we're searching for that right side value, when the array at that specific position is greater than the target, right? If it's equal to the target, we want to move the low pointer, right? We want to push it in that direction. Okay, so that takes care of the pointer reassignment. And then, of course, we just need to reassign the midpoint to be equal to math.floor of our high plus our low, and we will divide that by 2. Okay. And then at the very end, when we finish looping, we just need to make sure that the current midpoint equals the target. If it does, then we'll return that midpoint, that index for that midpoint. Otherwise, we want to return -1. Okay, so let's just do a short bit of recap here. So we're returning 2 calls to our binary search function inside of search range that just is going to return the index of that target value on the left side here, and then on the right side here. So we define these helper functions to help us decide our looping conditions. So the first function, left function 1, is the while condition for our for looping in our binary search. which is just stating that if the array at the current position does not equal the target, or the array at the current position -1 equals the target, then we are not done. We need to keep doing our work. And then our pointer reassignment, we want to reassign the high pointer if the array at the current position is greater than or equal to the target. And then for the right side pointer, we want to do the opposite, right? We want to keep looping while the current value does not equal the target, but also while the value at that index +1 does equal the target. And then here, we want to reassign the high pointer only in the case that that current position is greater than the target. Okay, and then our binary search, we're defining a midpoint here, and we're defining our looping condition, which we took care of in these helper functions. And then also resetting our pointer, which we're also taking care of inside of these helper functions. And then we're reassigning our midpoint to be the floor, again, of high and low divided by 2. And then we're just returning the midpoint only in the case that that position that we end up on is equal to the target. Otherwise, we're going to return -1. Okay, great. Let's see how we did. Okay, looks like I have a little bit of a bug here. Did not get through this bug free. Okay, so unexpected token, line 19. Okay, so, oh, that's right. I need to do a question mark here for our ternary. Let's try this again. Okay, great. 72 milliseconds. So as always, there's a conspiracy against me by LeetCode to make me look like I'm a terrible programmer. So what we're going to do, like we always do, since a couple videos ago, is rip the very best solution from LeetCode and test it against our code. So let's try that. Okay, so let's grab this 1%er here. Well, it doesn't look like a 1%er, it's like more like a 10%er. Okay, and we'll copy this. And go back to our code. Okay, great. And we'll paste this in. And let's see how we did. All right, great. 80 milliseconds. They're not better than us. Nobody's better than us, right? I'm just kidding. But anyways, so we've been crushing binary search lately. I think you guys should all feel really comfortable with binary search. And I hope anytime you see a sorted array, and someone's asking you for login runtime, and you're doing search, I mean, binary search, it's a no-brainer, right? We can do this in our sleep now. We've written binary search functions like 4 times in the last 2 videos. So anyways, I hope you enjoyed the video. I hope you learned something. And as always, I hope to see you in the next problem.